Welcome to the conversation seminar series this afternoon. I'll just acknowledge the tribal and Yagara people as the First Nations owners of the land where QUT now stands. We pay respect to their elders, laws, customs, and creation spirits. We recognise that these lands have always been places of teaching, research, and learning. QUT acknowledges the important role Aboriginal and Torres Strait Islander people play within the QUT community. So welcome to this afternoon's conversation series. We are very lucky to have Muge presenting today. Just a quick reminder of the format. We have 1 hour available. We start with a short presentation by Muge, somewhere between 20 to 30 minutes. And the idea of this is to really have a conversation. So I've asked Muge to maybe raise 1 or 2 points that might start a conversation. And then you're also very much encouraged, if you want to ask questions, to actually unmute and treat it more like a seminar. I know we're very used to webinars where we have thousands of people and people ask questions via chat. What we were trying to do here is actually just have a smaller conversation. There's also, so you can also ask questions via the chat. There is a Design Lab Conversations channel on Slack if you want to post something that crosses multiple conversations. And if you want access to the recording of the slides, please email Shelley on the QUT Design Lab Coordinator email address that's listed down here. Okay, quick introduction. Dr. Muge, Fialho, Leandro, Alves, Teixeira. Muge is a creative maker and transdisciplinary designer with specialisations in advanced manufacturing, digital fabrication, and parametric design. She is a senior lecturer in the Interior Architecture study area at QUT School of Design. She is one of our chief investigators at the QUT Design Lab, and she is also chief investigator in the Design Robotics project and the Advanced Robotics Manufacturing Hub. So those are projects, I think, where a lot of Muge's interests are coming together. And today she's talking about Transarchitectures, and I'll let her explain what she means by that. And she will showcase some of her creative work that's been represented by non-traditional research outputs, and sort of where she used a combination of robots, augmented virtual reality, sensors, and digital fabrication. So just one last slide, a quick sneak preview of the upcoming presentations. Next month, on the 19th of October, we have Associate Professor Veronica Garcia Hansen talk about her work around lighting design and other work that's related to that. And then the last 2 presentations this year are going to be about projects funded by the faculty within the Design Lab. The first one is on augmented and mixed reality in architecture, engineering, constructions. We'll be going to give an update on some of the early outcomes of the project. And the last one in December is about another project on salutogenic hospital design. Okay, so without further ado, I might hand over to Veronica. To Muge. Veronica's next month. There you go. Stop sharing my screen.
I'm not ready.
Yeah, sorry about that. So Muge, if you want to share your screen and take it away.
Thanks, Marcus. Let me share my screen. Can everyone see it, or? Yeah. All right. Yes, so welcome, everyone. Today I'll be talking about Transarchitectures and what it means, and also some of the creative research that I've been working on for many years now. Basically, what we have been seeing, the effects of digital technologies in all aspects of human life, and we, as designers, we also should be welcoming all these new technologies and embrace them in order to be more creative and be open-minded and experimental. And that's what Transarchitectures mean for me. So borrowing from different disciplines, learning from other approaches and bringing them, merging them all into this creative melting pot where we come up with these original artworks and responding to various research questions as NTROs. So this really brings us to the question of Cedric Price, like technology is the answer, but what is the question? In this presentation, I also would like to respond to that and what these questions might be for my research and how the creative output support maybe the suggestion for an answer for this question. So I will be starting with my first research project called Atmosphere. And I just want to re-emphasize, I know Marcus gave a bit of overview of my background, but I also am a founder of a research group with my partner, friend Teixeira. And most of these works, we have been collaborating together to create these outcomes. So I just want to acknowledge his contribution to them as well. So Atmosphere is a project from 2010 where we explored the idea of digital fabrication, and it's a sculpture that has a digital fabricated process, but at the same time a VR space that embodies it. You will see that in all these projects, I will be referring to some of the challenges of these technologies at times, especially with this one, for example. This was in the beginning of like 2010, where digital 3D printing was brand new, and we actually built this artwork in Turkey, and there were a lot of challenges around creating these type of complex geometries, and we had to go through various processes to build them, and we know that it's always challenging to use these new technologies, and there's always resistance to embody new upcoming tools and technologies. But what we believe is essential to actually embrace them, because these gives us possibilities to enhance our disciplinary knowledge, but at the same time lead to new areas of research where we explore unknown possibilities. And I think it's really important to share these challenges and outcomes. So whenever I have a chance to talk about my work, I tend to really explain them in detail, in relation to their design process as well. So coming back to Atmosphere, this project was a design, like I said, that had a physical and a virtual environment. And the idea was, it was borrowing these concepts from biology and morphogenesis as a design understanding, and looking at how we can apply these type of emergence behaviors in cell formation into an architectural form. As you can see, this is the genetic kind of classification, and it all emerges from one type of a code, which is called the Gastrulation process. So this process is where actually the cell is starting to interact with another cell, and being informed by the external elements, it starts to shape and create its own unique formation. We borrow this concept, and you can see here those cell differentiations in relation to different cells communicating with one another and creating really complex or divergent elements. And all of this is starting with signal processing between the cells and their relation to one another, as well as their relation to the environment. So taking this idea, we come up with a code. At the time, we were using Maya as a design tool. So Maya is a software that generally animation and used for animations and movies and 3D modeling. And in this case, we used different cell types. So you can see here, there are different core cells, and they have a predefined kind of interaction with one of them. We defined when they meet one another, they start to communicate with one another and start to send signals to each other. So these elements, which are kind of spikes in each core cell, will start to deform or extend or shrink depending on its relation with its neighboring cell. It's a bit of Conway's game of life, where you just set the ground rules and then allow the cells to interact with one another to create these complex geometries. So over time, these cells, when they communicate with one another, they evolve into these abstract forms. And so once these cells are created, then we 3D printed them at the time. Like I say, we used a powder printing system and created this type of natural landscape, which is also using the same code, and placed them on this sculptural element, which was then informed, actuated with sensors, because what we wanted to do is the sculpture to respond to the various activities that are happening around it as well, which would then be enhanced with the virtual experience too. So there are these kind of signals that are coming out of each one of these cells, which have certain elements that start vibrating depending on the different sensor input data. And then once they start to move, so the sculpture is a bit in a way kinetic in that way, it also changes some things that are happening in the background in the virtual space as well. So in order to understand and fully experience space, you need to be engaging with the physical sculpture, but at the same time with the virtual environment. So the setup basically is this artwork on a plinth, and then there's the projection with actuators, infrared sensors, microphones that are embedded within the sculpture itself. The users engage with it using a gamepad to move in the virtual space. And also when they walk closer to the sculpture would respond by using its sensors. So it was exhibited in a gallery space in order to engage with the public and with other people to experience the space, which has all the elements of different perceptions. So there's the visual elements, there's sonic elements, and there is also the kinesthetic elements. And while you are moving through the virtual space, you also experience this different perspectives and different views that you engage in and you discover within that virtual environment itself. So this work was initially designed for a lab space called TransLab in University of California, Santa Barbara, which we had the motion tracking system that you could actually walk in the lab space and you would be fully immersed in that virtual environment. But when it was exhibited in this gallery space, you would use gamepads to basically navigate through that VR environment. And all these VR elements, sound and sensors were embodied together in a software called Max NSB Jitter, which is usually for VJs that they use it in live performances, and so they are really good at computing real-time engagement and responsiveness for that matter, which is very similar to Grasshopper today. If you look at it, if you look at the similar software, it's similar type of a visual programming language. So here is a small snapshot of the VR space that you can move through and explore. As you can see, the quality of the rendering in today's conditions is not is much more developed now, evolved now, but at the time it was the best you could get by means of computing and you know, graphics wise. And here we see one of the structures is changing and responding to the movement within space. Its color saturations are changing and the sounds are changing. It's flickering because of zoom, I think. It's because when you real time move through it, it wasn't flickering like that. So the next project that I want to show is a design project that we were invited to take part in Istanbul Modern Art Museum. It's called 1 + 1 = 3 Systems of Didactic Communication. And in this case, we were exploring the potentials of AR as a way to teleport oneself from the physical world into the virtual world. And that interrelation between the two worlds that are seamless when you are using such a technology. So this was an ad hoc kind of an art exhibition. So it was supposed to be exhibited on certain times of the week and on and off. So we had to be very clever about the way we created the artwork. That's why we chose a medium which could be projected. So we were allocated a space where we could use a projection space that could be displayed all the time, and then people would go in there with their smartphones and they would scan a QR code to download a virtual model, and then by using the camera in their smartphone, they could immerse themselves into that projection space, and the physical model would overlap with the digital, which is within that projection. And we were exploring the idea of learning, because the exhibition was on educating the new, upcoming centuries, and it was about discovering, and we thought learning could only be done through experiencing space. So it would have been a sensorial experience that you had to move through space in order to understand its potentials, and design was part of that learning. So people would have to download this virtual model, and then in order to be able to immerse within that space, had to walk within the gallery room and explore the different potentials of that projected space. So these are some of the images from that exhibition space, and some of the experiments we did with our computer screen to see the potentials of this AR system. So here you can see how it might have looked within that space. And the third project that I will be talking about is the one in Montagu, which was exhibited here in SLQ, in State Library of Queensland, which was again a physical artwork with a VR environment. And in this case, we were exploring the idea of urban interiority and how we could represent an experience of the urban space and create a kind of environment that you can actually move through and understand the potentials of that urban interiority. So in this project, we actually were commissioned as part of the Home Suburban Obsession exhibition. I don't know if anyone has seen it, but this exhibition was about Brisbane and the homes of Brisbane. So it was exhibited for around 6 months in the gallery space. And they had invited, they wanted to bring a new approach to their collection. So they invited different artists with different backgrounds to create a design response to the art collection that they have, which was 300,000 photographs of homes, various homes from like 70s from Brisbane suburbia. So our response here, you can see the sculpture in the exhibition space was this artwork, which we call the one and the multiple, which was responding to the idea of the Coralis collection. So Corley, he was a very interesting guy that would just walk, like drive a pink Cadillac through streets of Brisbane, and he would take photographs of different homes. One of the, I think if you want to see the images or the Coralis collection, it's still available and online. You can just search home, State Library Queensland, and you would it would pop up this virtual space with different homes. Many of these homes were not identified because some of them has been demolished or some of them has been rebuilt. So they crowdsource this collection for people to actually reach out and identify several of the homes. So you can go into this collection and then write where you think the home was, or if you have lived there, you can write some of your memories that you have in that space, and even attach an image that you have taken from a long time. So it's still accessible. So this was Corley. I'm not sure if I won't probably show the whole movie, but this was a type of work that he was doing. He just had these cameras that he would drive with his Cadillac, sometimes not even coming out of his car. He would just stop by and take a snapshot of the house. So in some of the images, the house is like even tilted, or it's even not well aligned. And then he had this very interesting coding system where he would code and identify the street locations. And then once he was done, once he had the film, he would just pass the camera roll to his wife, who was parked in the premises in a caravan. She would then tap the images, and then they would have these people who would sell those images to the homes, back to the homes, either as forms of calendars or as forms of artworks. So we did a similar approach to Corley. So we were fascinated with the technology, the way he used technology. So we borrowed this LiDAR scanner, and we just very roughly scanned the streets of West End, because that's where we lived and that's where we felt attached to. So we chose one of the streets that still had some original Queenslanders, and we did a very rough scan of that street. And we also used photogrammetry and drone recording to get some of the skyline and the of the buildings. Through this rough scanning, we informed the 3D modeling of the digital environment, and we also used some machine learning code in Grasshopper to actually stitch some of these point cloud models into the physical sculpture themselves. So all the VR space was done in Unity, and then the physical model was done through Rhino and fabrication. So for the physical space, which hosted the VR environment, so the headsets and the cables in the computer, we chose this corner house because it was misaligned in the grid, and it had shown a potential that we were curious to explore further in the context of urban interiority. And we run this algorithm to calculate the shortest distances between the points in this corner house, which then created this this sculpture itself. And with we had a budget to build this work. So with the constraints, we had to adjust the resolution of this sculpture several times. And the sculpture is actually now here in D block on the first floor. If you might have seen it, it's a black box. So this is how it looked in the construction documents. Then we send it to a welder. We used again Grasshopper to create these manufacturing templates, which were automatically created with the dimensions, and it was also color coded for assembly, and it was built in two segments. Here you can see it in display in SLQ, so people could just go and it had the VR HDY system, and you could just use it to explore the VR space. So this is how the VR space would look like. So it had this kind of a resolution where you could still explore the space in your own pace, in your own curiosity. There were some images of Coralis Collection within the VR space with the actual photographs, and it was quite an interesting experience. So during the exhibition, we had a lot of issues when students would come and hack into the VR controller, and they would we would find it uploaded a totally different thing, or you could see some people were really hesitant to put the VR headset on, and there was a lot of prejudice around that it would make them dizzy or sick, or it was quite a challenging process actually. So I would like to acknowledge the Shinoa and Adam Jeffords for inviting us to be part of this exhibition, and Shue and Ben for supporting us. This work is still going on, so it was demoed in ACM SIGGRAPH Asia, and then it was exhibited in ADR conference in Melbourne, and we just recently wrote a paper about it in Idea Journal, so it's still going on. So the last project that I'll talk about is the Roboblocks project, which probably many of you have seen because it was it all happened here at QUT, and we spent a lot of time in J block as well to drill the holes into these spaces, and this work was exhibited in BAD and also Robotronica as well. So I want to talk about this time the use of robotics as part of the creative endeavor. So Roboblox came to us as a proposition to exhibit in Design Biennale in Istanbul, which was, the idea was this is the art gallery space, which had a little robot in the middle of the art gallery. So different groups from different places in the world would send their code and also the end effector that they would like to use along with their codes, so that the host group in Istanbul would exhibit the process, but at the same time build the artwork throughout time through the exhibition. So here you can see our section where we decided to work with a hot wire cutter and foam as a way to build our space. We were allocated a certain location within the art gallery's exhibition space, and here one of the conditions of that of this exhibition was to run a workshop with students and share the outcomes of that workshop as well. So as we did a workshop here in QUT, and so in the exhibition, like you could see here, there were screens where you could actually it would show the process of design as well. So all these videos were exhibited there. So the idea is of this Roboblox game is it's a website. Again, it's a rule-based game where the edge conditions are defined. So it's based on the works of Thierry Foucault from Oulipo movement in France. And the idea was that if you know the edge conditions of a design element of a tile, this was designed as a two-dimensional, like a tile painting looking like tile, then you could connect any type of edge conditions that match that edge condition. And then within the tile itself, you could be free to do anything you want. So we uploaded this rule into a web-based platform using the basis of these rules. And then you could change rotation magnitude and slides to create different variations of the form. And then export that file. So these are some of the outputs of the workshop where students explore them. And then you could export this into a Grasshopper, where you would actually use the robot to manufacture directly from that digital process. So being it in a website, it really allowed people, anyone that could have a link to that website could actually go in and personalize their blocks and then send it to the robot to be cut on site. So this work was exhibited in Istanbul. It got a lot of interest, and this was the kind of artwork when it was being built all the time. So it was a stacked kind of a barrier around the robot itself. And then we continued developing the game, and we exhibited here in BAD as well. So these are some of the videos of that Roboblox game. We used the robots at UQ to cut the blocks because they have a bigger, stronger payload robot. And our robots were busy with our own research project as well. So we collaborated with UQ to build this. Basically here we are just adjusting the robot and then just calibrating it and then sending the code to the robot, and then it just cuts these blocks one by one. You can see here the Grasshopper simulation of how it looks. And then let me see further ahead. Yeah, oh, here. And then each blocks were placed in this type of a grid, and we milled through wires to be able to assemble them. And currently this research is continuing on with it's more sustainable material like clay. And we are also looking into embodying AR because we found it very difficult to set up the final artwork. It was very hard to detect each block because they look very similar to one another. So we are exploring the potentials of AR in this as well. So I guess that's all I want to say. And it was a monologue mainly, but I'm really more than happy to answer some questions. I guess we just need to find more creative ways to involve different technologies into the way we design, because it does create new possibilities, and it's okay if it fails as a point. Maybe the technology is not there yet, but from that exploration we can actually learn a lot, and I think really push the limits of our disciplines and know-how. So yeah, you might have some questions around how we made some things, or what we got as a feedback from the audiences, or anything else. Please share your questions through either chat, or let me stop sharing. And
Excellent. Thank you very much, Muge. Thanks very much for this very exciting presentation. Let's put our hands together if we can, virtually or real, to thank Muge. Okay, excellent. So let's open for questions and see whether we have any questions from the audience straight away.
I can.
Okay, yeah, sure.
Yeah. Oh, Muge is beautiful. I love it. All the things that you show. I don't know if I have a question in particular. I just wanted to say that. I do have questions. But so that project about the street, so what did you use to scan the environment?
So we use the LiDAR scanner.
Yeah, the LiDAR scanner. Yeah.
And so UQ owns one, so we use that one. And we also used drones, and we took some photos, and we used photogrammetry for the top parts of the buildings. And then we stitched them together in QUT Compare, which is a software that has that capability.
Yeah, and so is that why it looks all kind of? Why does it look like kind of unfinished?
Yeah, so that was kind of intentional, because when you are moving through an urban space, you actually, when you think of that experience, it's more like you have resemblances or bits and pieces of that experience. It's never a full image. So we wanted to explore that idea further, and also when you move through that, unfinished or unclear views, it's a bit like surreal memory, and that really encourages you to explore it further. So we found that people who got really into that space, who wanted to know more about that space, would spend more than 20 minutes just walking through and exploring the space. I don't think I mentioned, but there was also the sounds that the recordings that we have from the street that went through different algorithms, again using Max MSP to then reflect really abstract voices from the street as well. So it kind of responded to all those different senses.
Gorgeous.
Right. I think Anastasia had a question as well about the LiDAR.
Yeah, I would just first of all, thank you, Muge. That was amazing. The projects, they're really, really cool. So yeah, I was wondering what LiDAR you were using. Is it because I've heard that they now are available in some iPad Pro series. So which one?
You can see it in the images, actually. In one of the images, it's the one. It's quite big. It's like a tripod, and generally use it for construction, and it's one of those pro versions.
Yeah,
I'm expensive.
I'm looking for LiDAR.
And just to follow up on that, and with the drones, you just use sorry, I think my connection is dropped.
Yeah, I think you are freezing, Marcus, or is it me? Because I can see Anastasia normally, but Marcus froze, maybe.
Yeah, no, he's...
Oh, okay, he dropped in now.
Yeah. So finish your question, Anastasia.
Yes.
For a solution for one of my projects where I need to attach a LiDAR to some kind of drone, I guess, and just along to the whole river line. And I'm just looking for some kind of cheap solution, which I'm afraid is not there. So.
No, this one was a very it's quite big and bulky and heavy. I can actually show you the. Okay, let me share my screen. Share, and then here. This one.
Okay.
This guy here.
Yeah, it's huge.
Yeah. But I know that at QUT, so I talked with the library, and they have this camera it's from GoPro, and it has like both sides has cameras, many cameras, which can take that. And I think QUT has this video where they flew a drone over QUT campus, and it's kind of like that interactive image type of a thing. So you could borrow that from QUT. I don't know what you want to do with it, like what kind of information you need from it. But if it's very highly realistic kind of environment, then that might do the job. Was it called Omni something? Yeah. GoPro.
I think the Visor Lab has done some LiDAR scanning as well on the stage. If you want to,
yeah.
I don't know whether they have their own equipment or whether they borrowed it, but I've seen some material there.
Yeah, they have, I think, some at Visor, some 3D scanners. Not sure if it's LiDAR, but yeah.
Right. Yeah, I'll check with Visor. Thank you. So basically, I need a scanner for get some spatial data, but in terms of it, I mean, we need some sort of geographical scan. So I would see the layers on top of water and underwater. So that's what I'm looking for. It's not like I need a high-res scan of something. It's really I need to able to see through. And that's what I need.
And that's why maybe point clouds is more what you're looking for rather than those rendered images. Yeah.
Thank you.
Hilda has asked something to chat. She says, can you actually make things in VR space? Yes, I mean, you can.
So yeah, I just asked online because I have very unstable internet, but yeah, obviously I would want to do that as a, you know, for instance, virtual design, fashion design, draw it in space. And I'm just wondering where on earth to start with something like this, even just to experiment. What would you suggest, where to go, what to do? Or is that too big a question?
No, not really. I mean, actually, sculptors or character animation artists already has been using VR to sculpt, you know, sculptures, virtual sculptures. So they also have these haptic tools where they can actually use their hands to inform the material and deform. A similar setup had been set at UIP, so our industry partner in Urban Arts project, which they are using Oculus, and the software that they are using is called, what is it? It's part of Oculus Medium, I think, yeah. And in that sculpting software, they can actually edit. They use it for architectural facades or balustrades to deform and change its materiality and edit its 3D form. So it is possible. I can send you some email about that software afterwards, or push it into Slack channel. So how they are using it is, for example, they had this artist called Emily Floyd who made these little toy mannequins, and she was commissioned to build it in a larger scale, like almost 1.5 meters. So the way they scaled that little mannequin was that they 3D scan it, and then they put that into that software from Oculus Medium, I think. I'm terrible with names, so I might be saying something wrong. So anyway, and in that, when they scaled it up, she wasn't very happy with certain parts of the parrot, so she wanted to sculpt it to its perfection. So she used that software to make it perfect, and then after that, they used that digital model to manufacture it. So there is a pathway to do that. And we have Oculus now, it's Design Lab, right? So you could look into that software.
Right. Any other questions? I had one. I might follow up with that one. Sort of, I think it's super interesting to see sort of how you use creative practice approaches, but then also in something that's situated in a design context. I'm wondering to what extent these projects have helped you with thinking about design and what design can do.
I think it's unlimited where we can take design to, right? But using technology in ways that it's not expected is, I guess, where my interest is, because it then creates these potentials and new findings, which is really exciting. And I think that's part of the trans approach that we have, transdisciplinary approach that I have, using technologies or using methodologies or using, you know, biological codes in an unexpected way, and see where it takes us, what the potentials are, and always looking for that that unexpected wow experience and surprising effect in a way. But if you look at all the works that I've shown today, they're all related to the way we perceive our environment, the way we move through environment, and the way we experience space. So they're always spatial. And I think, like, it's not a mystery anymore. It's going to be part of our daily lives, the connection between the virtual and the real. In many practical ways as well. So why not explore its potentials in artistic or designery ways? Because you can always then apply it for real world settings, or, you know, as industry applications as well. Once you know its potentials and limits and possibilities, it gives you that possibility to apply it as a, you know, real world solution, let's say.
Excellent. Yeah, that's great. Excellent. Any other questions from the audience? Okay. Good. All right. Oh, hang on. There's one. Yeah. Sorry.
Nice presentation, Muge. I just wanted to ask, because of the topic on Transarchitecture, did you mean it's Transarchitecture because of the process that involves? Or is it Transarchitecture because of the outcomes or the people, the experience that you expected through the process?
I think it gives itself a character, like it defines the outcomes in such a way that you won't be able to create these spaces unless you were using a transdisciplinary approach. So it's a bit like a chicken and egg situation, I guess. So following a transdisciplinary approach informs design of these spaces that are that could be named Transarchitectures because of the way they perform or the way that they exist in a way. And so they're all kind of connected. And that was like part of my thesis argument as well for my PhD, on how we can learn from these other disciplines in order to derail from the current trends that are happening around you. And then through that derailment, you kind of push the boundaries of your knowledge and create new knowledge.
Yeah.
And then,
I was interested because I've like always seen these your products, as well as I heard that you're talking about like Parasma and how like architecture and how we like phenomenology of architecture. So that's why I was trying to connect the dots, and I was trying to clear my understanding of what you mean by Transarchitecture.
Yeah. So it's called transvergent methodology, that you it's evolution over time, like you learn from these other disciplines and build on your own discipline and explore new areas of knowledge, and that kind of gives you the potential to create something in your own discipline, maybe, but in a way that it's not explored before, or it's original in a way that it's and it's quite a challenging, because if you show these spaces to, for example, to architects or to interior architects, they might have a hard time relating to them as interior spaces. Or so yeah, it's a bit challenging to communicate this type of research. So I'm really looking forward to this publication that I just wrote on Idea Journal, which is a very traditional journal for interior design, and I'm curious to see the feedback from that and see what they're going to say about it. Yeah.
Cool. Thank you.
Thank you for the questions.
Muge, I've got another question, if possible.
Yeah, sure.
Once we discuss Transarchitecture, I mean, first of all, I'm not familiar with the terminology at all, and with the methodology in that field, but I'm just trying to find a parallel with, you know, how a modern artists, they use science as an inspiration tool, and they build up all the, like, some projects on the principles of used in science.
Mm-hmm.
Interesting. So, and like, let's say in architecture, of course, it's not new to use the biological principles.
Yes.
And so on. But is there something where the architecture is built upon some, and I understand the parametric design is maybe a part of it, but is there something like where the architecture is using principles of, let's say, generative art or something like that? So where, like, you know, the computer algorithm creates something based on something else, where the architecture can look at and use it as a principle somewhere. So is there any examples for that?
Yeah.
Collaborations or experiments?
Yeah, currently, so we hosted through Design Lab as well. Last year, we hosted a researcher called Muhammad Maki. He's the founder of Wallacey, which is a plugin for Grasshopper. It's based on generative algorithms. So it's an engine that you define the environment, basically. So as architect, you define your parameters. And his example was through design of an urban block. So he would say, I want an urban block with a certain ratio of a courtyard and with certain building heights and some other parameters, which defines that environment. And then it goes into this generative algorithm that spits out millions and millions of species and possibilities. And from there, as an architect, you choose the one that you want to apply for your design. So it's becoming more and more common to have these type of algorithms. There are currently two trends. One of them is the Wallacey, and there's another one called Galapagos, and those are also from Grasshopper. And they, yeah, because initially, like when we were doing the Atmosphere project, let's say, we were setting up the rules at an interaction level, so that we would just run the script to see what would come out of it. So we would get, depending on the way we adjust the parameters of that script, we would get, you know, clusters or more linear formations, or we would explore these possibilities. But at the time, it was like really, what are these people doing type of approach. So yeah, but there had been some architectures, there's someone called, he's now working for Autodesk, what's his name, Christopher something. So I can send you the links of him as well to see how it's applied in the context of architectural design, because those are like professionals that work as architects.
Right, I would, thank you. I would definitely be interested in like learning more about that, and I will be probably contacting you soon, maybe asking for maybe like a meeting or something, just to discuss directions of what can be done, like in terms of tangible something out of completely digital something. Yeah.
Yeah.
That's good. So please join me in thanking Muge again for this super interesting talk. Thanks very much, Muge. And
thank you for organizing.
No worries. Thanks everyone for joining, and have a pleasant afternoon. I'll see you next time. Bye.
Thanks, Meg.